multiplicity of each zero is the number of times a factor occurs in factored form of the polynomial. Here's what I mean by this. What does it mean to cube something, just in general? Multiply by itself 3 times, right? So if I wouldn't normally write this out this way, but this is what this means. X times x minus 3 times x minus 3. How many factors of x minus 3 are there? 2, right? Which I got from that. So what we say then is, for this one, if I set this equal to 0, I would have x equals 0 would be multiplicity 1. Because how many times do I see it? Once. We would say x equals 0 has a multiplicity of 1. But when I solve this, x minus 3 equals 0, what would the 0 be? Good. Positive 3. How many factors of that do you see? 2. So I would say multiplicity of 2. You don't have to write it out this way, but sometimes that helps them because they're like, oh yeah, I see it multiple times. How many times do I see that factor? All right, let's put this on the graphing calculator and let's refresh our memories about what happens here. Okay, so we see a 0 at 0, we see a 0 at 3, but what happens when x equals 3? It bounces off. It does not change signs, does it? It doesn't go through the x-axis. Okay, so I'm going to just point that out. That had an even multiplicity, and that's what happened. This had an odd multiplicity, and it went through. Okay? All right, what does this one mean? Well, this really, you don't have to write it out if you don't want. But this really means x plus 1 times x minus 2 times x minus 2 times x minus 4 times x minus 4 times x minus 4. By the way, if you did all the multiplication, which I would not ask you to do, but if you did, what would be the degree of this polynomial? 6. Okay. All right, let's do the zeros. Let's address this one first. What would make this factor 0? X equals negative 1. What's the multiplicity? So I'm going to just abbreviate if you're okay with that. Multiplicity of 1. All right, the next factor is x minus 2. What would be the 0 if I set those equal to 0? X equals 2. How many factors do we see? So we would say multiplicity of 2. And finally, x equals 4 would also make this function 0, and that has multiplicity of 3. So, do you understand how to find the multiplicity then? If it's in factored form? Let's take a look when you're done at the graph of this and see what we see. Okay. Goes through at negative 1, bounces when x equals 2, goes through at 4. Let's summarize then. At a 0 with an even multiplicity, the graph of the function will do what? What do you want to say? You can say bounce, but what I want you to also write there is not change signs. It doesn't go through the x-axis. Okay, in other words, it's negative it has 0, then it still is negative because it's below the x-axis. That's what I mean by doesn't change sign. At a 0 with an odd multiplicity, the graph of the function will, I'll say, go through the x-axis, and it does change sign. Yes. What? Is there a change in the curvature? Is that what you asked? Yeah. So if it's a power that's greater than 1, you're going to see kind of like almost like it looks like a little of flattening almost. So a change in the rate of change, I guess, as well. So what she was saying is, like here, this was a degree of 1, or a multiplicity of 1. It goes kind of straight through, okay? But this one was degree 3. Do you see how there was like a little bit of a change of the flattening out? We actually, in calculus, call that a change of concavity, of how the function is curved. For now, really, you just need to know that it does go through. Reed, what was your question?
Is it a function?
It is a function. These are not vertical lines. They are very steep, but they are still going off to the right. All polynomials are functions. Okay. So, what we're going to do next then is let's put everything together. Let's use our knowledge about end behavior and about zeros, and we're going to sketch a picture of the graph. So, first of all, what is the degree of this polynomial? 4. To find the zeros in the multiplicity, sometimes they'll be factored, like in the one next to this. In a second it is, but this one is not, so let's factor this. Somebody help me out here. What would I do first? Take out a x squared. If I took out a x squared, then I would have left x squared minus 25. Can I go any further? Yes. Okay. So, by the way, be careful. This doesn't say x plus 5x plus 5. This is not a multiple root, but this is. X squared really means x minus 0 times x minus 0. Okay? So we have x equals 0 is a 0, and it has multiplicity 2. So that one is going to be one that bounces. We have x equals negative 5, which has a multiplicity of 1. And then we have x equals positive 5, which also has a multiplicity of 1. So then we should address the end behavior. It's degree 4, so tell me what you remember. Degree 4 means the end behavior is both going the same way, right? Is it going to be up, up, or down, down? Up, up, because this is a leading coefficient that's positive. Okay, so the way I would write that, we should practice this. The limit as x goes to negative infinity of f of x equals infinity, and the limit as x goes to infinity of f of x equals infinity. They're both infinity. They're both going up, both directions. So for our sketch, we are going to make sure that this is opening up And we need to make sure we address this. So let's do our sketch. Some things we will not know about our sketch, and today if I ever ask you to find maxes and mins, we can't do that algebraically. Well, you don't know how yet, okay? But you could do zeros algebraically, right? By factoring. So I'm going to put on here 1, 2, 3, 4, 5. That's -5. Here's 0. 1, 2, 3. Okay. And I'm going to start by going through -5 like this. I'm going to have the function bounce at 0. It's curved though. Don't make it like a line. Bounces at 0, and then, oops, goes through at 5. I don't know how low these go. I don't know, but that's what I mean by a sketch. The end behavior and the zeros. So I didn't go low enough, see that? But I don't care. Don't go back and adjust it. Alright. I want you to try this one on your own.